Looks like my stream is running well now. So, yeah, guys, welcome to my channel. I'm Val Vlogs, aka Shubham, as some people might know me. My stream is running well. I am currently a part of Hack Club. I just joined, I'm pretty sure, 2 weeks ago, and I'm enrolled for the follow program. I am from Chennai, India, and I am currently working on Valve Deck, which is going to be a type of Steam Deck which is completely customizable by the user, including the 3D design part, which is the chassis for the Steam Deck. I wanted a customizable Steam Deck, like not just a functionality, but also like the design, a very customized one for a very long time. I thought I would like this program would be a perfect opportunity for me to actually put it into place. So I don't really have any prior hardware knowledge to be exact. I've been to the CVSC Skill Expo Nationals, but I've only done the software part of the project for that. So I don't really have any expertise towards the hardware point of view. Before me, I've only worked on very simple stuff like Arduino and Moisture IoT devices. So don't expect me to know a lot of hardware. Please do excuse me if I go into tutorials a lot. It's only gonna be short ones, I promise. But yeah, so let's start working on Deck. Today my like to-do task has like to actually set up a GitHub for it and to make a schematic. Setting up a GitHub is gonna only take 1 minute. Let me just make this right here. Deck. It is available. Custom Steam Deck for myself. Let's add that in. It's public and yes, let's create a repo. Now that we have had this, let's actually start on the actual project. I just installed KiCad like 1 week ago as well. I don't really know how to use it very properly. This was just demo one. Let's make a new project now. Default. Okay. Let's Valve Deck. Now we have a schematic editor. So I was planning on using a Raspberry Pi Pico for this because it has a lot of GPIO pins. So Pico. It's like we do have a lot of varieties here. I am not sure about the difference between them as well. This one is the one I was looking for. It has 22 GPIO pins. We have the ground there. It's only it's a 3.3 volt. Okay, that's the extreme one. Hmm. Pretty sure it's this one. So let's get this started on. Yeah. Hmm? Hmm. So let's search for some switches. I do like mechanical switches. So let's go on mechanical switch types. So we have a lot here to see. Let's actually pick something like seen a few. I already like chose one. So it's on my phone. I'll just be back. So we have Cherry MX as well. So Cherry MX was one of my choices. Do we have stuff like that here? You won't find that here, will we? Yeah, so I already have no idea about what I'm doing. I'm pretty sure like it's gonna be enough for us to make a 3 by 3 matrix here and like just use 3 GPIO pins, like 3 rows and then 3 columns, so 6 will be used, I'm pretty sure. Then we'll connect the ground of every switch to the ground, and the VCC will be, yeah, it's quite easy to access, so that's not a big of a deal, but I don't know what type of switches to use right now. And absolutely no idea about how to import it into KiCad, so let's search that up. Okay, so libraries, I've heard this before. So yeah, this will probably work now. How okay, now we'll have to look at another tutorial on YouTube about how to install libraries. Is anyone watching my stream yet? Ah, that's okay. So it's just gonna be a 1 minute tutorial, I'm pretty sure. That's a lot of stuff. I don't understand it at all. So um we'll be adding, looks like I'll just have to go here again. Hmm, Look this up. Okay. So we have a zip folder here. I'm pretty sure I have to put this inside somewhere. So let's just extract all, extract it here. Nice. So now we have a lot of stuff to work with, I'm pretty sure. Hmm. Okay, so there must be a .lib file somewhere here. Do I just put this whole thing inside the program files? Let's see. What do we have? Program files. Well, SkyCAD. I absolutely forgot where I installed KiCad. So I'll be working on that, but also I can be importing libraries here, I'm pretty sure. That was that YouTube tutorial again. Play symbol. Preferences, manage. Okay. So system libraries. That's how you access them. Have KiCad library already. And then let's just import it from here, I'm pretty sure. Okay, which one do we import? It has to be a .lib file, but I can't find it here. Nope, and not here as well. So I guess I'll just have to here again. Extract all. So this is even worse, so I don't really know how to do this, man. Okay, it's okay, we'll figure stuff out along the way. But first, let's see how to make a 3 by 3 matrix. Matrix and KiCad schematic. So once we get a small thing, okay, let's not do that. Just KiCad. Looks like we have a lot of designs here. Let's just see how to make a matrix. Okay. So this is a button matrix. And yeah, this is probably something which I do want to build. Is this done yet? It's not. So let's first figure out how to do this. I have a good idea about this. So let's just extend the wire till, let's say, here for now. So we can pull one set down here. Yeah, that's it. I did not mean to do that. Oh, I'll be back. I am utterly confused about this. And yeah, this is the video which I was looking for.
With the buttons by using something called a keyboard matrix. I could have each switch directly connected to a pin on the controller on one side and 5 volts on which all the switches and one pin connected to each of column of pin. I'll instead have one pin connected to each row of switches and one pin connected to each of column of switches. Now I'm only using 6 pins as opposed to the 9 I was using before. But this raises the question, how does the controller know what button is being pressed? And the pin fine with the 2 buttons when it's not on each button. This is which button will prevent the current from.
I get it now. I get the structure, but now I'll have to look for libraries though. That's gonna be a bit of a hassle. Actually, start from here. So that one is done. I seriously need my switches now, and hopefully no one is watching because this is quite embarrassing. Yeah, so Let me actually look up some switches right now. I'm on my phone. So look up. So I'm searching it up right now, but compare plugin. Oh, so I could have easily just done this. Wait. Okay. Control M. So Control M. That did not work. Control M. That also did not work. Hmm. Project Manager window. Plugins. Okay, let's go to Tools and let's go to Plugin. I don't get this part either, so where is this again? Oh man, this is this is kind of painful getting started. So,
Window to the plugin you want. To install the plugin and content.
oh, I guess I can just go here then. Plugin context manager. Yes. Um. Okay. Okay. E-Blaster. Yes, I don't have the seed. That's really great. So now I get to add one. Okay, save. Let's go to E-Blast this one. To install. Okay. Install master lib. Okay, let's directly install Why is the install pending? Is it because I have this open? Looks like I can't really do anything for this. Yes. Now let's go here again. Install this. So now I'm pretty sure I should be having these install and also install this just in case there's something wrong because I don't know what I'm doing right now. Yes. Now let's open this again and I better get some Cherry MX switches. Wow. So what am I supposed to do now? Must be a next step. MX, okay, just MX. Pretty sure this should be coming in, right? No, um, so we have officially spent like what 20 minutes just trying to figure out what a library is and how to install one. But I guess we have installed it now, and yeah, I'm still not able to find it. It's not MCU. Am I supposed to reopen KiCad or something? Guess I might as well just do that. So I'm done with this. I'll open KiCad again, schematic. Oh wow. So I just had to open this again. Nice. So I've got a lot of new switches here. Yeah, so this is what I wanted. We do have a lot of switches here and I don't really know what's the difference. So these are memory flashes and so let's just start off with the normal switch first because I don't want to waste any more time. It's a solder one, that means I'll have to be careful about the positive and negative ones, I think. So I'll just go to normal. No, stop. No. So that is where it is connected to wire. Okay, so it is like that. No. If I do this, it will change this. Okay, I get that. So now let's refer to the 3 by 3 matrix one again.
As it
And
turns out, there's a pretty cool way I can directly connect it to a pin on the controller on one side and 5 volts on the other. When the switch isn't being pressed, or now I'll instead have one pin connected to each as opposed to the
so I'm going to try to have a matrix for all of these things. That is one for this and one for this. I don't really have an idea about what I'm supposed to be doing for that, but wish me luck. This is what I was using, I'm pretty sure. Okay, so it does not rotate like that. So I will look at the 3x3 keyboard matrix again. It's the type of macro part actually what I'm making, so that's gonna be good. No. First we'll have a 3x3 matrix, and then we will also add the volume now which I was talking about. This video will explain
So
it
today
to
I
me
wanted
in
to talk
quite a
about
good
the
way.
ground, and then this is indicating a connection on the controller. Now the way a switch, this is going to our controller. So control object with diode schematic for our diodes, and what a diode does is it only allows an anti-ghost.
So actually, yeah, this is quite a good design with what I'm seeing right now. So keeping it a bit more organized, we can name this column 1, column 2, and column 3 as well. So this is getting deleted, and that too is getting deleted. Okay, let's go mx and yes, this. If we keep this one right here, I have to draw a connection for it here as well. I guess that's fair enough, because I'll also have to add a diode because it is a keyboard. So copy, and then okay, put another one here, copy, we'll put another one there. Okay, so now I think that is quite complete. We'll put another one here, another one here, another one here. The names are actually taking up a lot of space. So now we're done with placing the night switches. I don't know why it's so far, so let's just copy all that and put it here or something. Let's delete that. Wire coming from here. Shit, that was not supposed to be like that, but okay. We'll be going towards ground again, so that is that.
You can see that the diodes are connected to the row here, and the
And before we actually connect it to the second row, we will be having to place a diode, so that's an important point again. This one got quite diverted, didn't it? Okay. Yes, so now that is connected, and now that's this app. Do this. Now I'll have to individually see the this wire tool is annoying. Let's just go like this, and then We'll keep the names according to the matrix count. So this will be this will be 1 1 1 2 1 3 2 1 2 2 2 3. Okay, it'll be like that. 2 1. That's nice. Let's keep it. Okay, we'll delete that. Not part of the plan. And we'll put it back here. Now we will put this as 2 1. We'll keep this entry empty. Parenthesis must start with a letter. Looks like I'll have to put a reference here as well. Let's keep it 1 0 to be in more computer-like terms. We'll keep this space. Keep this as A, and then we'll keep this as 0 0. Be 0. My bad. Be 0 1 and A. Be 0 2 and A. 1 3 A. 1 4. It's my bad. 1 2. Actually, be 1 1 here. 1 A, and this will be 1 2. Now again for the third row it will be 2 0. 8 2 1 A. This will be 2 2 A here. Pretty sure no one is watching. Yeah, so no one is actually watching my stream. That's a good thing. I think so. Yes, okay. Continuing with my work again. So here we'll be having to add a diode. Let's search for diodes. Small. Pretty sure this will be working well. It's actually quite large. Guys, it might be kind of disappointing, but looks like we'll have to be changing our plans. So basically, yeah, we copying these though, putting them down. How much of a gap was this from here? Then we'll put this one here. Yes, so that works out quite well. Let's copy this and put this here, and also here. Oh, my bad. So it actually does not work like that. It's supposed to be a bit longer. That's equidistant. So that is equidistant, guys. Just copy this part again. Put one here and we'll put one here. Here, put one here, put one here. Using diodes to prevent electricity from going back. So I'm pretty sure that will work out. I hopefully it does at least. This is gonna be my first time, guys, so no judging. Wire connection. No. And that is a very wrong wire connection. I don't know what went wrong there. Yes. Stop. It's not supposed to be like that. Yeah. It's okay. You're done with that. Okay. Now that we are done with that, we'll be connecting these to what am I supposed to connect that? Let's look at the reference again. So these have been like this guy is using an Arduino Pro Micro. I mean, we might as well just use a smaller chip actually, which will be, more power efficient, more actually cheap. It will be more functional. We don't really have it for like heavy tasks. So
10 by 10 way that on for the detects it. Diodes is pretty simple. Boards really pad, which means we need a total of 6 pins on our controller.
so pretty sure that's it. We just connected to the like GPIO pins now. Pretty sure we can just do that. So let's connect this one here. No, this one here. This one. No, wait. This one. Actually, I will keep it in a 2 block distance. There. Oh, so that part has been done. And now for the other rows. I mean, I kind of messed up, guys. Excuse me for that, but these have to be different columns, right? I connected them here. So I'll just cut off these wires. Looks like I can't. So that's a very horrible thing which we are going through now. Can't I just please cut off these wires? Why is it not letting me do that first? So I'll just remove this. Remove this. I'll remove this as well. No, I'll let that. Yeah, we'll remove this. Move these namings on these. Yes, so we are done with that. Now we'll be putting a wire here. Great. Um, so now that is also done. What happened here? No. Here it is. Why is it acting that way? Delete this. I will also delete this. Now putting a wire down the road. Oh, okay, I get the problem now. There's this tiny part of wire which is disturbing them. No, the wire has actually been combined here. I'm pretty sure that's not gonna. Oh, might as well take it out. Drawing a wire again. My bad. Then we are done. I think. I don't know. So now to make it more organized, we'll just take the name of the resistors out. I mean diodes out. Mm, Taking that as a reference was actually quite a help. So we'll cut these off. Venom, delete and delete. Pretty sure these switches will work because just in case if it does not work, I'm very much cooked. Um, just search this up again just in case it has any restrictions. Is this something like that? Oh no. What is that? Excuse me, gang. I might have just is that even a mechanical keyboard piece? Take this to the easy editor. We'll look at the foot button again. Yes. This is what I used, I'm pretty sure. Guys, I think I might be into big trouble here because if this does not work, it's a PCB socket, going to make a printer. So yeah, uh, pretty sure if I attach those switches on top of this, it'll be working. So hopefully, I mean hopefully yes. And that being done, I think I'm done with the diagram. I'll just remove these. What's this? Yes. So that is done. Are we now going to require any power supply? What's this? It's a bill of material file. That's nice. Um, okay. So looks like this is the final structure. We have a 3 by 3 keyboard matrix, which looks good enough. What is the ground pin? I mean, am I not supposed to have a ground connection here? Um, just a second. No one is in the chat yet. YouTube Studio. had 8 views, and I'm pretty sure, yeah, all of them by me. That's fun. But yep, now that we have done this, I'll be taking a break of 5 minutes and I'll be back.